And I wanted to do one, if that's all right with people, just based on interactions with everybody. It seems like elasticity of taxable income, sort of the EITC stuff, are the most popular functions to look at. How many people want to do elasticity of taxable income first instead of EITC? How many people want to do EITC or welfare first? Okay, it looks like elasticity of taxable income wins. And that's partly good because I did EITC in the review last week, and that video is now online, so you can take a look at that as well. There's also 2 EITC practice problems in my Friday review notes, one of which was a problem set question last year, the second one. So if you want a really elaborate look at that, you can check those out. But we'll still talk about EITC. So let me give like a scenario here with the elasticity of taxable income. So what we're going to do here is, so remember again, you'll be given this formula on the exam, along with the net loss formula. Right? So you're going to get both of these. And remember that you can use the elasticity of taxable income in for this elasticity here. Right? So let's look at one potential elasticity of taxable income type of question. Right? So we might tell you that the elasticity of taxable income is equal to 0.8, let's say. And we have an individual, so we have like Joe, and he earns $100,000, right? And his tax rate is 20%. Right, so he's taxed 20% of his income. Right? Now we're going to raise the tax rate, so that's kind of the setup. Right? We're going to raise the tax rate to 50% on Joe. What is the effect on government revenue from this increase in the tax rate? That's the question. So that's like our question here. So again, the elasticity of taxable income is 0.8. Joe is earning $100,000, and his tax rate is currently 20%. That's the current state of the world. And now we're raising that tax rate to 50%. What's the effect on government revenue? So I'll give you guys just a minute to get that started. Oh, sure. And this again, I'll just put right up here. What you'd be getting. The first step here, just to make sure we're all on the same path, is what's government revenue to begin with?
20,000.
20,000. Right, so part A might actually be what is government revenue before the tax increase, right? Maybe ask that. And how did you get 20,000? We multiplied 100,000 by 20%. Right, so we're kind of simplifying away from marginal tax rates, and it gets messier there, brackets and all that. So we're just saying 20% on all your income. The government revenue used to be, I'm going to call this government revenue number 1, was 20,000. So how are people starting to set this up? Somebody want to tell us, like, what's maybe the first thing they wrote down for calculating the new government revenue? Yep.
You have to find the percentage change in the taxable income.
Okay, and why? Like, what are we using? Like, why do you think we have to find that?
Because when you change the tax rate, you're going to change how much people are earning to begin with.
Right, exactly. So we know the tax rate, but we don't know what Joe is earning. If we did, we'd know revenue. Right? That's the first important point to realize is, well, the effect on government revenue. Whenever you see a question in this kind of, you always want to ask, what information do I need to know to figure out that number? information do you need to know government revenue? Well, government revenue is tax rate times income. I know the tax rate is 50%, I don't know his income now. So I clearly need to find out his income. And you see right here, we've got elasticity of taxable income is what's given to you, so you can immediately say, well, this is the formula for that. So I need to use this somehow, right? So, so we're just going to kind of recreate that formula. The elasticity is the percentage change in taxable income divided by the percentage change in 1 minus the tax rate. Okay? So what in this formula do we have? We have the elasticity, it's 0.8. And so this is 0.8. What about on the right-hand side? What do we have from here? We can compute the denominator, right? What's our before and after for the denominator? This denominator went from, what was 1 minus t before? 0.8. And then what is it now? 0.5. So we need to know, what is that percent change? Well, you do the change in that number, which is minus 0.3, divided by what it initially was, which is 0.8. And that's the percentage change in that this change represents, right, which is like minus 3.75. Oh, sorry, 0.375. Which you can, pop in a calculator or whatever. That's another thing. If you want to use a calculator, you can't use your phone or anything, so we won't allow that. So today, going to Staples and buying like a really one of those second-grade calculators would be a decent investment of money. You will not be allowed to use anything advanced at all. So we've got the denominator as 0.375 with the minus sign in front of it, right? Because that's what we got from there. Right, everybody agree with that? Yeah, do you have a question?
How do you get the 0.8 to the denominator? Sorry, I missed that.
That's just the initial, right? Going from here to here, that's a decrease of 0.3. To get the percentage change, you have to divide by where we were to begin with. Right? It's like when the price of a shirt goes from $100 to $75. That's a 25% increase. How did I get that? $25 decrease divided by the 100 that it started at. It's just the denominator for percent change. Right? So it's like 0.5 minus 0.8 divided by 0.8. Okay, so you can see we're kind of almost done with this. We just need this numerator, percentage change in TI.
Wait, but I thought we still multiply by 1, the negative 0.375 is something multiplied by something else.
No, because this negative 0.375 is this. It's the percentage change in 1 minus t. Right? 1 minus t was this, now it's this. That's the percent change, and that's the denominator. We're not computing it yet. You're right, we're going to multiply by the elasticity and all that. But I'm just going to keep this formula. I'm asking myself, okay, I plug that in, I plug that in. I need to get this. Right? And so you're kind of the next step, probably, which is okay, now what do I do? I have this. I don't have this part. So clearly this is I need this. Right? I need to get the taxable income change. But there's only one unknown, which is that. So I can now compute the percentage change in taxable income by doing what I think maybe you were getting at, which is the percent change in taxable income is this times this. We can rearrange this formula. This is the elasticity formula, right? So I can just now rearrange it because I know this is true, right? So I multiply 0.8 by 0.375, minus 0.375, we get the percent change in taxable income. And you multiply the left and right side of this equation by the denominator here. Right? Is everybody with me there? Right? To get, what does this have to be? This is equal to 0.8 times this. So I'm just multiplying the two sides of the equation by that denominator. So we get 0.8 times minus 0.375 equals the percentage change in taxable income. Right?
I think it would be clear, Sion, just to know that the denominator, it's like a formula that you wrote on the board, the professor, like 1 minus t nu divided, no, I'm talking, yeah, exactly. 1
This
minus, 1 minus T, the new like tax
Oh,
rate?
yeah, so the beginning,
Minus
that's,
This
1
0.3
minus
over
2.
0.8 is the percent change, but I don't.
this is this is like 1 minus t to begin with. And that's new, sorry, old. And this is 1 minus t new. Right? So I use that to compute the percentage change in 1 minus t, which is this. Right? That's the old one, that's the new one. So to calculate the percentage change, you do the difference between them, new minus old, divided by old. That's this. That is the denominator. This is exactly the same as price elasticity of demand. Like, it's exactly the same calculation. There, the denominator was what? It was a percentage change in price. We did like price, new, old price. We did calculate the percentage change that way. Now we're just calculating the percentage change from this to this. Just two numbers. And what's the percent change moving from this to the other? So that tells us this is the denominator. Because this is this. Right? The numbers that we know. And now I can rearrange this formula by multiplying both sides by minus 0.375, and I get this percent change in taxable income as a number, as this times this. Right, which should give you minus 0.3. Right, so what is that telling us? It's telling us that the taxable income has to fall by 30% here. Do I know what the old taxable income was? Yeah, it was 100,000. So what does the new taxable income have to be? 70,000, because it falls by 30%. This formula tells me that. Right, so the percentage change in TI is 0.3. You can think of that this way, right? Is that this, what is percentage change in TI? It's TI new minus TI old divided by TI old. Right, that's the formula for percent change. And TI old here is 100,000. Right, and I know that this thing has to equal minus 0.3. So I can plug in old. I know the old one is 100,000. So I get TI new. Oh, sorry. I get TI new minus TI old. Oh, sorry. Minus the 100,000. Excuse me. I'm plugging now. TI old is 100,000. Divided by 100,000 equals minus 0.3. And then you just solve for TI new. It's the only non-number up here. Multiply both sides by 100K, add 100K to both sides, you'll get 70,000. Or some people just like jumping right to it. If your old one was 100,000, your new one's got to be 30% less. Just multiply the old one by 0.7. And you're done. So you get taxable income now, TI new, you should get 70,000. But remember what the question was. What's the effect on government revenue? So what's the new government revenue? 35,000?
Yep.
How did you get that? All right, government revenue is income times tax rate. And it's the new tax rate. So that's going to be 35,000. So the old government revenue, sorry, this is like called government revenue number 2. The new government revenue is 35,000. It used to be 20,000. So government revenue goes up by 15,000. Or, you could also say it goes up by 75%. But, that's fine. So that's how you compute like the effect on revenue. You got to use the elasticity of taxable income formula. We've also got deadweight loss. So you want to be able to compute the effect of this on deadweight loss. For that, you got to use the deadweight loss formula. Right, so what if this question, part B, was the effect on deadweight loss? I'll again put up the formula that you are given again. Right here. Just folds. So now we're asking the effect on deadweight loss. And just to remind you guys of the numbers, 100,000, tax rate was 0.20. After we just computed taxable income, 70K. I'm putting up the after taxable income. So let me just, we can just nip this above. Do I need this? I don't need 70K. So that's one important point to make. You don't need to ever use this. Just notice the deadweight loss formula has elasticity in there, so that behavioral change is incorporated already. You can just use 100,000 and use T1 and T2 to compute deadweight loss before and then deadweight loss after with these two. You might say, but I do need to incorporate the fact that it goes down to 70K, but don't worry, that elasticity term is going to be doing that in the computation already. The WH here in both calculations, before and after for deadweight loss, is going to be 100,000. So does somebody want me to talk to what was the deadweight loss old? What did you multiply? Yep.
Deadweight loss is 1/2 times 0.2 squared. So that's the old tax rate squared times the cost.
What's
Oh,
missing?
sorry.
We're missing something.
What's missing? The elasticity.
Okay,
Okay. Which, sorry, I forgot to put that up here. Elasticity was 0.8. Sorry, that was my fault. Right. That should be in there, and that's this, and that's, but you might say that's the elasticity of taxable income. But we're using that as a proxy for elasticity of labor supply. Right, so you have to have the 0.8 in there. And if you want to keep it consistent looking like this, that would come after the 1/2. Right, so that is our old deadweight loss. So I don't know if people have somebody has a calculator, pop it in. 1,600. And our deadweight loss new is going to look like what? It's going to be 1/2. Now we have 0.5 squared. We still use 100,000 and 0.8. Right, so what do we get for that? 10,000. Notice for a couple things. First, I used 100,000 again. Why don't I use 70,000? Because then I'd be double doing the effect of the tax increase. This 0.8 is the elasticity of taxable income. It takes care of that for me. Right? You might say, but it was there before. Well, now it's being multiplied by a bigger number. So that the fact that the tax is going up is being multiplied by this actually takes care of the behavioral change, the new taxable income. You can use the old earnings. So that's actually a really important point, and one that people kind of get confused with a bit. Yeah.
We touched on this in class briefly, but just for the exam, I want to make sure I know what you're right. When they ask for deadweight loss, are we supposed to put any sort of unit down?
Yeah, I think you can say that the deadweight loss is it's in dollars, but that doesn't mean that it doesn't have the same interpretation as the deadweight loss did in like markets, right? Where we were like it was dollars of surplus. It's not quite the same thing here. It's a little bit more complex than that, but I mean.
Or should we just, is it okay to not put a unit for this?
I would. That's a good question. I think we've used all that. I mean, let me check this. So I think we've been using dollars throughout, but just knowing that the debit that's not necessarily. We're trying to say debit loss. We're trying to capture the effect of this policy on like social welfare, and that's like not properly accounted for by saying that it's that many dollars, right? Because whose dollars? Like who is ultimately the one paying those $10,000? So.
$10,000 worth of exchange.
I would just say the deadweight loss increased by $8,400, and leave it at that. Because it is in dollar terms, it kind of depends on the units, and it's not a perfect measure. It's not perfect to say that it's dollars, but I think that's good enough for our purposes. Yeah.
The midterm solutions from last year just say the deadweight loss decreases by 750.
Okay, yeah, I mean, I don't think if you put units or you don't, I don't think that'll really matter too much. But that's a good question. Maybe I'll send her a clarifying email. I just want to double check what she uses, but different people use different things. Okay, so everybody's sort of okay with that computation? So remember, deadweight loss, you use the deadweight loss formula that you're given. Elasticity of taxable income, use this one. And the more you can kind of tell yourself that this is the same, it's just calculating 2% changes, just like we did with prices and quantities, P1, P2, Q1, Q2 last semester. It's the same thing here. Now we have 1 minus T before, 1 minus T after, taxable income before, taxable income after. And then revenue is just like, well, you do one more computation at the end, and that's just knowing how to compute a revenue, right? For the government, it's your income times the tax rate. Okay, so that was the elasticity of taxable income problem. Are there any other questions on this or any of this stuff? Okay, so the nice thing is the formulas are there for you. You can practice these on your own if you feel like you need it. Is there a question?